Hi everyone, it's me, Carolyn, and in this video we are going to be talking about some more hypotheses testing, and we are going to be looking at a population proportion when we have dependent samples. So I'm just going to jump right into our guided notes and go from there. So we'll see how this looks. Maybe a little dark. Let's see. Gotta wait for it to adjust. Here we go. But it looks like if I turn the light on, yeah, there we go. All right, so we are looking at 11.2. And in this section, we're going to be talking about inferences on a matched pairs situation, so dependent samples. So first of all, the qualifications that we have to have is that we do have simple random sampling. Again, that is going to be in the design of the experiment, not necessarily something we can control. But before we do any statistical analysis on things, we want to make sure that the data was collected in a well manner. All right, we also want to make sure, of course, that it is a matched pair type situation. Otherwise, we should be using a different process. We also want to make sure that the data is either normal with no outliers, or we have those large sample sizes. All right, so first of all, the formulas that we will have. If we wanted to calculate a confidence interval, and I'll talk about what these pieces are when we are actually in an example. So for the differences in our pieces, we have this D bar. That's going to be the average of our differences. So D bar is going to be the average or the mean of our differences. T alpha over 2, again, is going to be based on the degrees of freedom, and -1 for the number of matched pairs. And as we do our example, I'll kind of explain all of those. SD is going to be that standard deviation of our differences. And then, of course, divided by the square root of n being the total number of matched pairs that we have. All right, so we have our hypotheses tests. Again, we have 5 steps. We should be getting pretty comfortable with these. Since this is a matched pairs, our hypotheses are going to look kind of like this. We will have that the mean of the differences is equal to 0. So we're basically saying that they're the same. Alternative hypothesis could be a one tail going in either direction, less than or greater than, or the two tail with our not equal. We find our alpha, which is usually stated in our problem. Our test statistic, which looks similar to some of the stuff we saw in the confidence interval. It is our D bar minus the 0. This 0 refers to this 0. In the real world, this may be some other value. But again, we are just getting a taste of all of these ideas. So we will have a 0 here. The standard deviation of our differences, and that square root of n. Notice it is a t, so we would be using a t-table if we were going to be doing this one by hand with tables. I will be using StatCrunch to kind of save a lot of the grunt work because there is a lot of grunt work in these problems. All right, step number 4 is to find those critical values, which are associated with the alpha. Again, we would use those getting from our table with degrees of freedom, or the p-value associated with our test statistic. Again, I will be, could do that on our table. Here, we would have like a space because we'd have to kind of guess as to what our p-value will be. I will be using technology to help us. We will decide to reject or not reject, and then we're going to write our conclusion. Okay, a matched pair situation is one where we have, again, to kind of remind you what the definition is, where one sample indicates what the other sample is going to be. Common ideas for that are a lot of times a test retest. If you have someone do a pre-test and the same person do a post-test, kind of to see, did we see improvement? Did we see not improvement? So a lot of times if that individual is in like a pre-test, post-test, or a before medication, after medication, before exercise program, after exercise program, that person is the two pieces. So of course they're dependent on one another. Sometimes you may have a twin situation where one twin gets this and the other twin gets that. So those two are matched, being twins. You may have the same person use two different clubs, like on a golf course, testing one club versus another club, or different balls, but it's that same person doing the same thing. So that's where we're seeing that matched pairs idea. You can have husband-wives kind of thing. So anytime you have some sort of connection between the two different measurements. All right, so our example that I stole from the textbook is taking a muzzle loader or a muzzle velocity, and we're using basically rounds fired from a 155 millimeter gun, and we're measuring it for two measuring devices. So here is one shot, measuring device A and measuring device B, measuring the same shot. So these are matched because this is indicating the two pieces. So these are connected to each other because they measured the same gunshot. Okay, so we have the following data from a muzzle velocity, which is measured in feet per second, in rounds fired by 155. For each round, two measurements were taken using two different measuring devices. And here is the data. And since we have raw data, that's why a lot of these things, we want to use technology to save us a lot of the mess. And I'll show you what it does for us and why we like to use technology versus doing it all by hand. It is a matched pair, as I said just a little bit ago. Each shot dictates the two different measurements. If we had completely different shots measured by them differently, so this guy measured this one, this guy measured a different one, then they'd be completely independent from one another. But since they measure the same shot, it is a matched pairs. And we want to know, is there a difference between the measurement of muzzle frequencies, velocity between device A and device B at alpha at 0.01? We are going to assume that this distribution is normal with no outliers. Because we only have 12, we kind of have to have that extra information. I'm also then going to, since we are talking about a difference going both directions, I'll get that confidence interval to kind of verify that piece as well. So we're going to start in with our hypotheses testing, and then we'll let, again, technology do all of the grunt work for us, but we still have to do some of it. So for example, we do need to write our hypotheses. We are looking at a matched pair, and we want to know, are the differences, are they different from one another? So are the differences equal to 0 versus not equal to 0? So we're finding, is there a difference or isn't there? Step 2 is our alpha value, which is 0.01. So I'll write that down here in my steps. Step 3 would be our test statistic, which we would calculate. D bar minus my 0, this 0 being this 0. S of D all over that square root of n. Now, n in this case, we have 12 shots, so that is our n. I'll put that piece in here, just so you know that that's where that comes from. Our degrees of freedom for these problems would be that 12 minus 1, which is 11. So we're talking about the number of matched pairs. That's our n that we come up with. Okay. Step 4 would be to find those critical values. I think I will do that real quickly here. Find my table. These are a T with degrees of freedom equal to 11. We're doing an alpha of 0.01. So our critical value here, just to kind of remind us of these pieces. So we are looking for, since we do a two-tail, we're going to have 0.005 in both of those. So 0.005 and going down to 11, I have 3.106. Okay, so I'm going to kind of, and we'll verify those when we get to 3.106. And since we're looking both directions, it would be the negative as well. If I had my test statistics, which is a lot of work, we're going to have technology do it for us, then we would be looking for that value somewhere on that line and get it sandwiched between two values is what we would do. So kind of reminding you how we would find p-values. Okay, but again, I am going to go to technology to do all of the work for me. So I'm going to switch to looking at StatCrunch because that's the technology I want to use. Okay, and what I did ahead of time is I did type in the information. So I have the data in here. So there's that measurement from device A, and here is measurement for device B. So you can kind of see those numbers all in there. If we were doing this by hand, the first thing you have to do is find all the differences. Difference meaning subtract all of these values. Then you'd need to get the average of those. And then you also need to get the variance of those, or the standard deviation of all those numbers. That's at SD. So you would have to calculate those two pieces. However, nicely for us, we do have technology that does all of the work. So I'm going to go, it is a T. Remember, that's why we had a T. And we are doing a paired. So this is a match paired. So we're doing paired. And it is expecting us to have data. Okay, most of the time we don't have the summary of all this stuff. So we have sample one is in come back here. Sample one is variable one. So there's my first device A. Device B is in 2. These optional things is not something we need to worry about. We are doing our hypothesis test. I will come back and do my confidence interval. Okay, so we're doing a hypothesis test. I do want to show my critical values to kind of reaffirm that value we got off the table. And I have that 0.01. Make sure you change it because default is 0.05. So we needed to change it. I'm also going to click some other stuff that we could get is the summary statistics. I'm also going to have them save my differences so you can kind of see them. Okay, so it will show the differences between the two pieces. And it does this so quickly that I could not have done this by hand even close. So first of all, in the data itself, you'll notice that this extra column popped in, and those are the differences that between the two. So it subtracted them, and you could probably have done that by hand a little bit. Subtracting those, we do get that 0.6. We got some negatives in there. Okay. The sample statistics here, some of the summary stuff that it does for us is it does look at variable 1 and variable 2, gives us means of both of those, the standard deviations of both of those. But the hypotheses test results are all right here. So again, remembering that mu D is mu1 minus mu2. So making sure we took this one minus this one. The mean of those differences is at 0.116. Our standard deviation, standard error. Our degrees of freedom, there's that 11 we talked about. There is our test statistics. I'm going to write that down on my piece of paper because it calculated it for me, and that's a 0.8517. So 85 is close enough. My critical values, notice they have some more decimals, but we had that 3.106, very close. And I'm also going to write down my p-value, which is 0.4125. Okay. While I am here, I will also get my confidence interval. So I wanted to get that 99% confidence interval. So I'll write that down as well. We're going to need our lower limit and our upper limit. So I'm writing these. Once I get them, I'll write them down. I'm going to close this, but we'll also go do this again. So we're doing a t-stat. We're doing paired. Our variable is in variable 1. Sample 1 is in variable 1. Sample 2 is our variable 2. This time we are doing a confidence interval. I want to do a 99% confidence interval because my alpha was 0.01. So I want to make sure that I get the same results. And I'll hit compute and move this over a little bit so I can see it better. Okay, you'll notice that our mean and our error stayed the same from when we did it before. Still that 11 degrees of freedom. Our lower limit is a negative 0.308. Our upper limit is a 0.542. Kind of going 3 decimals, which is close enough. But I wrote those values down. So now I have all my information from technology, and I'm going to go back to my guided notes. And it'll take a little while for this to come in here with all my new pieces. There we go. So I did write our test statistic down, which is 0.85. I did get our p-value. So we've done steps 3 and we got steps 4. I did both of them again. You do not need to do both. You do one or the other. But we do need to make our decision. If we're looking with the critical values, we kind of put this 0.85 in the picture. 0.85 would be somewhere in here. Okay. If we were testing using our p-value, we kind of look at it and say, is the p-value, kind of say, is it smaller than our alpha? 0.01. This is no. This is not in the shaded corner in the pieces here. So we will, or step 5 is we will not reject. It's not, which means there's not enough evidence. There is not enough, not sufficient, substantial evidence, enough evidence to show a difference in the measuring devices. So they are very close to one another based on our, well, we're not going to say they're equal, but we're going to say we can't say that they're different. Okay. We did also calculate that confidence interval, that negative is our lower limit, that positive is our upper limit. 0 is between those somewhere. So that's another reason to say that it is not rejecting. Since this value is in that interval, we're 99% confidence that the true difference is between those two. And 0 is between those two. So I'm 99% confident that I'm not going to reject that. So there we go. Hopefully you're starting to understand these hypotheses testing and how the confidence intervals all kind of play a role in statistics as we touch on different types of situations. Here we were seeing these match pairs. Again, good match pair problems are similar to a test retest, having someone do a pre-test, learn something post-test. Did we see the improvement? We sure hope so. If we do different exercise pieces, weighing someone ahead of time, exercising, or measurements, making sure their arms are getting bigger, smaller, whatever we want them to do. Is a drug helping, measuring pain before this new drug, pain after the drug, being able to, all the different things that happen. And these are the things that they do test in the medical world. They do test in so many different places. And match pairs is one spot that we do a lot of that. And this is the process that they go through. So hopefully you are getting a little bit of a taste for statistics. Hopefully you're starting to enjoy it. If not, I guess I can't do a whole lot to control that either. But I will see you all in the next video where we are going to be just looking at two completely different samples. But that's the next video. Have a great day.